Hello everybody. Today we're going to be talking about Visual Basic with the .NET Framework, and we'll be looking at project management. This is by myself. My name is Micah Holmes. And today we're going to discuss how to actually build your projects before we actually get into actually developing with Visual Basic. We need to understand how to even build a project. We need to understand the basic principles behind how we actually manage a project, or essentially how we plan a project. So let's go ahead and start with the with step one here. There's 13 steps to this, not to be confused with the 12-step program. Sorry, not affiliated and associated in any way, shape, or form. Anyway, so the first thing we have to do, though, as a software developer, is we have to identify the root problem, or problems, plural. Now, the reason why I say problems in plural, because we may be dealing with more than one problem. Now, when you're developing software, you will find commonly that you have multiple problems. Your boss is going to come to you and be like, look, I've got line 6, 8, and 9 down. Fix it. Your program, your program crashed on all of them. Fix it. And each one of those problems might be the same issue, or they could be different issues. It's going to be different every time you encounter an issue. So as a developer, you need to start finding the root problems before you even try to build the solution. Alright, so step 2 is identify the major issues. What's going on in my code? What exceptions are being thrown? If you haven't even developed the project yet, you might want to look at, what are the major issues that I need to overcome? Is there a performance issue? Is there, is it on the database side? Which side of the router is it on, essentially? These are things that you need to know from the developer's perspective. Where are my major issues, and what do I need to overcome? Not just the root problem itself, but there's going to be other issues as well. There may be as simple as, I don't know how to do that. Okay, well, I need to know that I don't know how to do that yet, but I know that that's going to be my solution, so I need to find out how to do that. So that brings us to step 3 when we identify our solutions. Just simply stating that, going off the previous statement that, I know what's wrong, but I don't know how to fix it. Or I know what's wrong and I know how to fix that, but let's say I know that I'm going to encounter other things that I don't know the answer to, so I need to know what the solution is going to be for that as well when I identify, solutions for that. One way that you can identify solutions if you don't know the answer yourself is simply go on the MSDN. The great thing about working with the .NET framework specifically is that we have the Microsoft Developers Network. And the MSDN is pretty much just a giant collection of other developers such as yourself, or people who are learning to become developers, who are trying to solve problems and create solutions, essentially, for projects. And you can go there and you can talk to several other developers and get answers to your questions. You can post your questions, or you can even answer some questions for people. So it's really just a great place to go when you have questions. You can also go out and search forums for tutorials and whatnot on how to solve your issues as well. However, the MSDN is probably, honestly, the best place to get the best answers because you're going to be talking to real developers and real engineers. One of the big problems I find with going to other websites other than Microsoft's website is that you get people who know just enough to be dangerous, essentially. They don't really know what they're actually talking about completely. They have this partial solution that's just kind of not that good. There's better ways to do it, essentially. So you want to probably try to stick with the MSDN. The next part is plan your project strategy and research. You need to plan a project strategy. Like, hey, this is the steps that we're going to go. This is how we're going to get there. This is our timeline. This is our time frame. Before you can even do that, though, you need to research how long something's going to take. If you have a strategy, you need to research that strategy and to make sure that it's going to fit into your time frame that you have. A lot of times projects will only have so many months before they have to be finished. And you have to research your solutions to make sure that your solution that you're providing or that you're suggesting in your strategy is going to be able to fit in that time frame. So research is a major part of your strategy. So make sure it's definitely included. The next thing you want to do is you want to define your project scope. Not necessarily just the scope of support, just the scope in general. If you have a problem with customer service and you have another problem with the database, let's try to define that scope. Let's just focus on one problem at a time. Customer service is obviously extremely important, of course, but you know what? If I can't even connect to the database to get the proper information that I need for my software to work in the first place, then I probably need to go with that first. That needs to be, in my scope, and I need to worry about customer support later, because you know what? Honestly, that customer support issue, with that scope of that issue, may be solved if I just, define my scope specifically with the database. So, you may essentially end up killing two birds with one stone, essentially. So you need to really define your scope, or your project scope. To really say, okay, this is only what I'm going to solve with this project. This is only in my realm of scope, or my scope of support, essentially, for this project. Alright, so that's really important. Don't try to do too much. Probably one of the biggest flops and the biggest failures I've ever seen with projects is they try to do everything all at once. It's not a very good practice. Try to define your scope. Try to keep your projects small, organized, and you will get them done much faster and more effectively. In the long run, it's just better to define your scope. Alright, next thing is develop samples. This is coming back to identifying problems and solutions and whatnot. If you think you know how to do something, before you take and start actually developing the actual product itself, it's a good idea to make yourself samples of pieces of the project or pieces of the solution. That way you know that this works. This portion of the code I know is guaranteed going to work, and I have this sample and I can play with it in case something breaks. Along the way I can go back to my sample and play around with my sample and see how it interacts with the project as a whole. Instead of destroying the entire project, I can just play with my samples and completely demolish those instead of destroying the entire main project. So that's a really good practice to get into, is to build samples. A lot of developers don't build samples. They get about halfway into the project and things start to fall apart and they're like, why did that happen? Well, because you didn't build a sample. If you had a sample, you could have known up front, what problems you're going to encounter. So it's really good to have these samples developed. One of the things that I've done as a developer, and I've been developing software for over 10 years, one of the things I like to do is I like to make a small scale. Of every project that I've done usually has a small scale. It has a very basic small scale version of that project. That way I know exactly what I'm dealing with. The entire process, it's not a guesswork. It's I know I'm going to have this issue. Here's how I'm going to solve that issue. The next step that we're going to be looking at is where you actually define the project roles. When I say define your project roles, you need to establish who's your project manager if you haven't done that already. Who is going to be responsible for, what sections of the project. Who's doing the marketing, who's doing the sales in this project. Where's the information coming from? Where's all the research essentially coming from? Who is doing what? Who is your artist? And so on and so forth. And it's really important to define the roles in the beginning of the project, because you don't want to find out that you're supposed to be doing marketing when you're doing sales, 3 or 6 months down the line, and the project's ending. Be like, oh, by the way. So you want to make sure it's very clear up front who's doing what, who's in charge of what, and just make sure everything's organized up front, essentially. The next thing, once you have defined out who's doing what and what roles and whatnot, this is when you actually start budgeting that project. You know how much these people make essentially. So you need to start figuring out how much it's going to cost if I pull Joe from accounting to do finance side of this project. How much is it going to cost, an hourly wage for him to work on this project? Or if I pull Bill from, I don't know, like sales or something, you know what he's going to be making or what he should be compensated. If he's working strictly on commissions, well, obviously you're going to pull him for a period of time. So now you have to switch from commission based to a hourly based. So you need to agree on what that wage is going to be. So this is where you start actually budgeting your project. It's a really good idea as a developer that you have a basic understanding of finances and some basic accounting background. Especially if you're a project manager, you really need to have that finance background, such as I do myself. I was actually 2 classes shy myself of an accounting degree, and I opted out on getting the accounting degree because it wasn't the direction that I wanted to go. However, that experience and that training and that knowledge is very helpful as a developer because accountants are really good at organizing finances. I mean, it's essentially what they've specialized in. So as a project manager, it's really good that you understand how to budget projects as well. The next thing is to actually develop the project. Once you have all the groundwork and the foundation essentially built for your project, you need to actually start developing the project. This is when you start finding out what works and what doesn't work. This is when you start finding out, if your plan was bulletproof or not, essentially. And once it's developed, you need to send it through some testing. The first test you essentially want to send it through is just a very basic alpha test, just to simply ensure that it actually works. Now, I know you're going to be testing your project throughout the entire process, of course. Every developer does, of course. We always debug. But this is the actual the first finalized product testing. This is when you actually get the project finished and you're like, okay, I'm ready to present this to somebody. It's completely done. I want to present this to the VP or whoever you're presenting this to. Like, hey, this is our first phase of testing. This is where we're at so far. This is what the project looks like. This is what it does. This is a really good idea to show this to them because now they can actually see what their investment has created. If you're working as a contractor, it's very important that you show your customer what their money went toward, and where you're at. They always want to know where you're at in the process, and unfortunately sometimes you have to kind of push them out the door and be like, look, I'm working, I'm busy. This is the part where you actually get to show them, be like, look, I'm done, I'm at a stopping point, I can show you what I have, this is what it looks like, this is how it works. We can start planning training sessions for your team or whatnot within X amount of time. The next thing is your beta testing. Beta testing is essentially crucial as well. A lot of people skip alpha, and I don't think that that's a good practice. You should not skip alpha testing. You need to go through the alpha testing phase and then go into your beta testing phase. In your beta testing phase, that's when you essentially really start digging down into the code and start really optimizing it. In your alpha test, you're simply just presenting it to people, and figuring out the basic mechanics of how it's going to work, essentially. When you're working in your beta, you already know the essential functions, you already know the basics of what works and what doesn't work. Now you need to go back and actually fix that, and then you need to do your fine-tuning, essentially optimize the project as well, and get it ready essentially for documentation and training. The last phase essentially is your live test. Now, just because you're throwing this in a live environment and you've already beta tested it doesn't mean that you should not still continue testing. The live test is probably the most important test of all, and I know this is a big test that a lot of people fail essentially because they think, oh, it's already done, whatever, just maintain it at this point. Not true. On your live test, this is when you're putting it in a live environment with real people. Let's say that we're doing manufacturing, essentially. Let's say we're doing an automated manufacturing process. It needs to be able to interact with people efficiently, essentially. And that's really, as a developer, from that perspective, that's what you're trying to do. You're trying to, make efficient software that, saves money, saves time. The process was taking 20 seconds, for it to get through this procedure. With your software, it should be, cutting in half. That was the idea or the goal behind the project. And right now, it's only, let's say it's only at like 15 seconds. So you want to shave off another 5 seconds. Really evaluate the situation. Look at where it's at. Look at how that person's interacting with your software. How are they using it? Are they using it correctly? Do they need more training? Is it a training issue? Is it a software issue? Is it a database issue? Find out what the problems are right there. Live testing is really going to tell you really where you're at, and really where you can go back and tweak it even further. Once you get through that process, you're still not done. You still need to maintain your project, and you need to consistently evaluate your project and the people who interact with it. The interaction and the maintaining of your project will never end. As long as that project is live, you will always maintain that project. And here's the fun part: even when the project is dead, it still has use. Old dead projects essentially are very valuable. Let's say you're upgrading from VB6 to VB.NET. You can really learn a lot of life lessons essentially by looking at that old program and see what you did right and see what you did wrong. That's why it's really good to keep projects, to document them very well, comment them, exceptionally well as well. Just have everything well documented on how the entire process went. If you're closing out an old project and updating it to a new project, maybe it's good idea to run that old project for a couple weeks, take notes on it, and see how well effectively it did actually work. And then when you redevelop it and create the new project, compare. Was the old project as good as the new project, or vice versa? If the new project is doing worse, you need to look at the old project and figure out what it did that was so much better, and try to replicate that. Because unfortunately, sometimes in a lot of cases with VB6, essentially, with Microsoft saying this is the last operating system that we're going to support it, and the last server environment essentially is going to be 2008, from my understanding. If your company upgrades within the next 10-20 years, and they're still using old outdated software, which I've seen Windows NT being used still, which is really bad, and that's just because they can't automate the process. Developer side, essentially, they haven't been able to find a developer that can do as good or better on the software side, which is really sad. That just comes down to poor documentation a lot of times, or poor evaluation of the software itself. You have to really observe. You're not only just a developer, you're essentially a scientist, essentially. And scientists learn by observing things, and that's really what you have to get into the mindset as a developer. You need to understand that it's not just logic, it's not just math. You have to observe. You really have to look. You have to consider the human element as well as the machine element, that's going into your logical code. People are going to interact with this in some way, shape, or form. You need to make sure that it works well with them. So maintain that project correctly, as well as previous projects, and consistently evaluate it. Write documentations. Just keep a journal on that project. Even if it's just like a 2-minute journal, once a week, once a month, or something, stating, okay, well, we were at this. Users say that it's performing efficiently, and then post some numbers, essentially. What the monthly earnings were, or whatever it is doing. Write down some kind of statistics for yourself. Because statistics are another big part as far as development goes as well, because that's going to tell you just how efficient your software is working. All right, so that's essentially project management, essentially, and project development. This is really important as a developer. I think essentially, as you take on the role, that you understand all of these 13 steps and you practice them. All right, so if you have any questions pertaining to project management and project development, and planning it essentially, and you think that there's maybe something that I might have left out that wasn't covered in the 13 steps, please feel free to post it. Otherwise, please subscribe, and I will have more videos for you guys as well about Visual Basic and the .NET Framework and the development. Alright, so thank you.